All, welcome to the Security Tube Linux Assembly Expert course and certification. Now in this video, we will look at creating Hello World shellcode using jump call pop. Now if you're wondering what jump call pop is, just bear with me for a bit. Now what we would find when we take our hello world.nasm which we created earlier and we try to convert that into shellcode, that there are going to be a ton of 0x00s in it. So we would have to go ahead and ensure that we replace all of that with non-zero opcode instructions. Now apart from that, please keep in mind that we cannot have any hard-coded addresses inside of a shellcode. And the simple reason is we do not know where our shellcode would be located in memory when it is delivered as part of an exploit. And hence, we will always have to work our way out and dynamically figure out the addresses of any string or any data which we would like to use within the shellcode. So let's try and understand the overall structure of our shellcode. Now, if you recall hello world.nasm, we have a string in there, hello world, which is defined. And if we go back and look at that program, let's copy it to the current directory. And let me open that up. Now, if you remember, in this program, we've defined hello world in the data section, and we are using that address in here along with the RSI register. Now, unfortunately, when we create a hello world shellcode, we cannot have this hard-coded address. We would instead have to dynamically figure it out. So let's go back to our slides. And this is where the jump call pop technique comes in. So the order is really, we have a jump which calls the label call underscore shellcode, which is in here. And at this location, we have a call instruction which calls shellcode, which is back up there. But remind yourself what call does. Call pushes the address of the next instruction on the stack. Now in this case, the next instruction is nothing but the address of the hello world string in memory, and that is what gets pushed on the stack. Now if you go back and look at the assembly language for hello world.nasm, the RSI register needs to contain the address of the hello world string. And that is why in the jump call pop structure, when we call shellcode and land here, the first instruction pops the top of the stack into RSI, and really the top of the stack contains the address of the hello world string. So this is how we set the whole process up to dynamically figure out the address of the hello world string. Rest of the work is really going to be to remove the nulls and change them with non-zero or non-null opcodes. So let's get to the job. Now I've copied hello world.nasm, which is what I'm going to use. Remove the data section. It's going to be part of the code section. Let's remove the length as well. I remember dynamically the length is 35 approximately. We put 35 in as a placeholder for the time being. And let's now create our jump call pop order. So here is what we're going to do. We're going to say jump, and let's follow what we had on the slides, call underscore shellcode. So let's have call underscore shellcode. Let's remove the comments in here. We don't need them anymore. And here is my label call underscore shellcode, where we are going to now have a call instruction, and this basically goes ahead and calls shellcode, which is right here. So we have call shellcode, which is really right in here. right? And then we have a pop RSI in here. There we go, right? Now, if we actually use NASM, let me actually bring down the font size a little bit. Now, if we use NASM, create the object code and use object dump to inspect it, we would actually find that there are a ton of zeros in there, right? All of them really in the move instructions. So we need to remove all the move instructions and replace them with equivalent instructions which does the same functionality. So let's get to it. Okay, so we notice that RAX and RDI both have the value 0 in them, 1 in them. So let's do this. XOR RAX, and then we can actually have a move AL1, and basically we can have a move RDI RAX. This basically does, really all it does, it moves the value 1 into both RAX and RDI, and then we have move RDX 35. So here is what we can do. We can actually convert this into another move RDX RDI, and then we can add the value 34 to RDX. Let's see if that has any zeros in there. Now move RDI 11 is not really required. You can just convert this to a XOR RDI. This kind of ensures that we return a 0 value from the exit syscall. And move RAX 60 can be converted into XOR RAX, add RAX 60. There we go. Now there are hundreds of such combinations possible. Over time, you can figure out which of these instructions occupies a smaller memory, a smaller size, and then you can go with it, right? I am not going to be working on optimizations right now. The whole idea first is to conceptually deliver the idea of creating shellcode to you. Okay, so now let's go ahead, call our good friend NASM. Now let's call object dump. Check if we have any nulls in there, and as you can clearly see, there are no nulls, right? So this is good enough. Now let's actually go ahead and use LD and link this to an executable. Try running this, and if you notice, it runs perfectly. Now we need to extract the shell code from this. So let me actually find the shortcut which we were using. There we go. Here is our shell code. Copy it out. Again, we can see there are no nulls in there. And let's copy out shellcode.c in here so that we can use that file. Paste that in. Compile, run the shellcode, and there we go, right? 71 bytes approximately. And we have hello world to the SLA 64-bit course as the shellcode which is now executing, right? Fantastic. So as far as playing with the shellcode is concerned. Now you can try and see how you can optimize it further as you desire by changing all of these instructions. You can see if a move is better than probably, an add, compare, contrast, and play with things in here, right? So hopefully this video was very clear and you enjoyed it. Try out this sample all by yourself. And if you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.